Welcome to episode 135 of Build Your House Yourself University by BYHYU. I'm your host and fellow student, Michelle Nelson, and together we'll learn the basics of home design and construction and demystify the building process so we can better understand our options and build quality dream homes with or without a general contractor. Building a tight house is the goal for most of us. What that means is that the unintended openings, gaps, and holes in the home's exterior shell and in the duct system should be sealed to keep outside air from leaking in and to keep inside air from leaking out. A tight house will be more comfortable and have increased energy efficiency and lower utility bills. That's because conditioned air produced by your HVAC system is less likely to escape, and unconditioned outside air is less likely to sneak in through unwanted gaps. A tight house is also quieter, cleaner, and has better indoor air quality because outside noise, pests, and pollutants have fewer opportunities to enter the home. If you've listened to past episodes, you know that if we build tight, we should also ventilate right. You'll hear old school contractors say that building a tight house is not a good idea because they argue that a house should breathe. Modern building science has proven that old school contractors are wrong to avoid building a tight building envelope. But the old adage that a house should breathe is actually right. But instead of the house breathing through uncontrolled air infiltration of a leaky house, we want a house with a tight building envelope that breathes through controlled ventilation. In this week's episode, we'll discuss ventilation systems for the home. Like last week's moisture control mini lesson, the majority of the information in this week's episode comes from the U.S. government's website, energy.gov. Let's get started. A tight house requires controlled mechanical ventilation to maintain good indoor air quality. A ventilation system takes stale air out and brings fresh air in. Without controlled ventilation, the air sealing techniques of a tight building envelope can trap indoor air pollutants inside the house. Pollutants like formaldehyde, volatile organic compounds, or VOCs, and radon. Another role that ventilation systems play is in the removal of excess indoor moisture, which, if left unchecked, could cause mold, rot, and structural damage. We learned last week about how to control damaging moisture in your house. For more detail, take a listen to episode 134 called Control One of Your Home's Biggest Enemies, Moisture. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE, has come up with a calculation that will tell you the appropriate amount of ventilation your house needs. That calculation takes into account the number of people living in the home, the number of bedrooms, how many stories the house has, and a percentage of the total conditioned square footage of the home. Ask your HVAC guys, your home energy rater, or builder to help you with that calculation to determine the amount of ventilation you need for your home. Now, let's briefly go over the 3 main ventilation strategies we can use: natural ventilation, spot ventilation, and whole house ventilation. Most homes should use all 3 ventilation strategies. Let's start by talking about natural ventilation. In a poorly sealed, leaky house, which hopefully we won't have, natural ventilation occurs with the uncontrolled air movement in and out of cracks and small holes in the home's building envelope. But in today's tight homes, intentional natural ventilation occurs when opening windows and doors. Spot ventilation. Spot ventilation can improve the effectiveness of natural ventilation and whole house ventilation by removing indoor air pollution and/or moisture where they develop. Bathroom exhaust fans and kitchen range hoods are examples of spot ventilation. And finally, whole house ventilation. Whole house ventilation systems provide controlled, uniform ventilation throughout a house. These systems use one or more fans and duct systems to exhaust stale air and/or supply fresh air. There are 4 basic types of whole house ventilation systems: exhaust, supply, balanced, and energy recovery systems. Exhaust ventilation systems work by removing air from the house. Supply ventilation systems work by adding air to the house. Balanced ventilation systems add and remove equal amounts of fresh outdoor air and stale indoor air. And energy recovery ventilation systems, or ERVs, and heat recovery ventilation systems, also called HRVs, provide controlled ventilation while minimizing heat loss. Now, let's talk about each type of whole house ventilation in just a little bit more detail. Exhaust ventilation systems. These systems remove or exhaust air from the house. This depressurizes the house. Exhaust ventilation systems are best for cold climates. That's because in hot, humid climates, the exhaust ventilation systems can trap moist air in the wall cavities, where it can condense and cause moisture damage. Typically, an exhaust ventilation system usually consists of a single fan connected to a centrally located single exhaust point. This simple system is relatively easy and cheap to install. You can also connect the fan to several rooms through a duct system and add window or wall vents to introduce fresh air. The problem with exhaust ventilation systems is that they suck. No, they literally suck. And if the system is sucking air in from an attached garage, a damp crawl space, or a dirty attic, you could be bringing in pollutants like dust, radon, mold, and garage and fireplace fumes. Supply ventilation systems. Supply ventilation systems use a fan to bring in or supply the house with fresh outdoor air. Supply ventilation systems pressurize your house, meaning they add air pressure to your home. Like exhaust ventilation systems, supply systems are relatively simple and inexpensive to install. A typical supply ventilation system has a fan and duct system that introduces fresh air into one or several rooms. This system can include window or wall vents in other rooms. As compared to an exhaust system, a supply ventilation system is better at controlling the quality of air that enters the home. Air brought in by the supply ventilation system is filtered to remove pollen, dust, and humidity. Supply ventilation systems work best in hot or mixed climates. In cold climates, supply ventilation systems can cause moisture to condense in the outer parts of exterior walls, again causing mold, mildew, and decay. Moving on to balanced ventilation systems. Balanced ventilation systems, if properly designed and installed, will neither pressurize nor depressurize your home. Instead, they introduce and exhaust equal amounts of fresh outside air and stale inside air. A balanced ventilation system usually has 2 fans and 2 duct systems. Balanced systems allow the use of filters to remove dust and pollen from outside air before introducing it to the house. Balanced ventilation systems are appropriate for all climates. But because they require 2 duct and 2 fan systems, balanced ventilation systems are usually more expensive to install and operate than supply or exhaust systems. None of the 3 ventilation systems that we just talked about remove heat from fresh air before it enters the house. Therefore, supply, exhaust, and balanced systems can cause higher heating and cooling costs, unlike energy recovery ventilation systems, which is next on our list. Energy recovery ventilation systems provide a controlled way of ventilating a home while minimizing energy loss. In the winter, these systems transfer heat from the warm, stale indoor air to the fresh, cold outside supply air. In the summer, the inside air cools the warmer supply air. This exchange of heat helps to reduce heating and cooling costs. There are 2 types of recovery ventilation systems: heat recovery ventilators, or HRVs, and energy recovery ventilators, or ERVs. HRVs and ERVs are similar devices in that both supply fresh air and exhaust stale air while recovering heat. The primary difference between the two is that an HRV transfers only heat, while an ERV transfers both heat and moisture. Both HRVs and ERVs include a heat exchanger, one or more fans, and controls. These systems include 2 fans, one to exhaust stale indoor air and one to bring in fresh outdoor air. There are also filters for both air streams. In the summer, an energy recovery ventilator may help to control humidity in the house. There is, however, some controversy about using these ventilator systems during humid but not so hot summer weather. Some experts suggest that it's better to turn the system off in very humid weather to keep indoor humidity levels low. HRVs and ERVs are more expensive than exhaust, supply, and balanced ventilation systems. HRVs and ERVs are the most cost-effective in climates with extreme winters or summers, and where the cost of fuel is high. In milder climates, you probably won't get enough cost savings to justify purchasing and running an ERV or HRV. In other words, for most homes, attempting to recover all the energy in the exhaust air will probably not be worth the additional cost of an ERV or HRV. Energy recovery ventilation systems require more maintenance than other ventilation systems. They need to be cleaned regularly to preserve their efficiency and to prevent mold and bacteria on the heat exchange surface. There's so much more information that you can read about ventilation systems. I just wanted to give you a brief overview in today's mini lesson. Let's go over a few key points with a couple of quiz questions. Question number 1. Which of the following statements are true about the 4 types of whole house ventilation systems? A. Exhaust ventilation systems work by removing air from the house. B. Supply ventilation systems work by adding air to the house. C. Balanced ventilation systems add and remove equal amounts of fresh outside air and stale inside air. D. Energy recovery ventilation systems and heat recovery ventilation systems provide controlled ventilation while minimizing heat loss. Or E. All of the above. The answer is all of the above. All of those were true. And question number 2. Which of the following statements is false? A. Exhaust ventilation systems are best for cold climates. B. Supply ventilation systems work best in hot or mixed climates. C. Balanced ventilation systems are appropriate for all climates. D. HRVs and ERVs are most effective in climates with extreme winters or summers and where the cost of fuel is high. And E. Both HRVs and ERVs transfer heat and moisture. Which one's false? The answer is E. E is false. Energy recovery systems transfer both heat and moisture, but HRVs transfer only heat. Well, how'd you do? I hope you learned as much as I did. And I hope you'll join me again next week for another episode of Build Your House Yourself University. BYHYU. Please remember that the purpose of this podcast is simply to educate and inform. It's not a substitute for professional advice. The information that you hear is based only on the opinions, research, and experiences of my guests and myself. That information might be incomplete, it's subject to change, and it may not apply to your project. In addition, building codes and requirements vary from region to region, so always consult a professional about specific recommendations for your home.